This video is for section 3-5, systems of two linear equations in two variables. When you graph two linear equations on the same coordinate plane, the result is one of three graphs. This diagram shows the three graphs. In picture A, these two equations create these two lines which look parallel. In picture B, these two equations create coincident lines. The graph of the second equation lines up perfectly with the first equation. In picture C, these two equations create these lines that intersect at the point 2, 5. If set S and set T are the solution sets of two linear equations, the sets can have in common no point if the lines are parallel. That was the first picture. Or all their points. That happens if the lines coincide, if one equation is equivalent to the other. That was the second picture. The equations look different, but they're really equivalent. If you multiplied the first equation by 2, it would create the second equation. The third possibility is there can be one point in common. That happens if the lines intersect. That was picture C. Two equations represent two conditions imposed on the variables at the same time. They are a system of equations. A solution of a system is an ordered pair that satisfies both equations. In picture C, the solution to the system is the ordered pair 2, 5. If you put a 2 in for x and a 5 in for y, the first equation checks out and makes -4. If you put a 2 here and a 5 here, the second equation checks out and does make a 12. 2 for x and 5 for y solve both equations at the same time. These pictures show that you can find the solution to a system if you have the graph. The first picture shows that this system has no solutions. There are no points in common for both equations. The second picture shows that there's an infinite number of solutions. All ordered pairs on one equation also solve the other. The third picture shows the solution is 2, 5. But what if you don't have a graph and you don't want to take the time to make a graph? You can still find the solution to a system using algebra. Algebraic methods for solving a system aim to find an equivalent system whose solution can be obtained by inspection. Inspection means that you can figure out the solution just by looking at the equation. Here are the transformations that produce an equivalent system of linear equations. So all the things that you can do to transform a system into a new but equivalent system. You can replace either equation by an equivalent equation. You can replace either equation by the sum of that equation and any real number multiple of the other equation. The replacement is called a linear combination of the equations. The third thing you can do is substitute for one of the variables an equivalent expression or its value if you know it. Let's try an example where we will transform this system of equations into an easier looking system that we can tell the answer by inspection. We're going to use a method called linear combination. Step 1 is to transform the first equation so that its y term is the opposite of the y term in the second equation. The opposite of positive 4y is negative 4y. To make this be negative 4y, we need to multiply by -2. Let's multiply the entire first equation by -2. It becomes -2x minus 4y equals -20. This is equivalent to the first equation in the system, but every term has been multiplied by -2. Let's rewrite the second equation as it is. Step 2 is to add these two equations together, to combine them together. -2x add 3x makes 1x. -4y plus 4y makes nothing. And on the right side, negative 20 plus 8 is negative 12. We have x equals negative 12. By inspection, we know the answer for x is negative 12. Next, we're going to redo step 1, but this time make the x term in the first equation be the opposite of the x term in the second equation. This is positive 3x. The opposite of positive 3x is negative 3x. So we would need to multiply by negative 3. Let's multiply the entire first equation by negative 3. It becomes negative 3x minus 6y equals negative 30. Copy the second equation down just as it is. Then in step 2, add the equations together, combine them together. Negative 3x add 3x makes nothing. Negative 6y add 4y is negative 2y. And negative 30 add 8 is negative 22. Divide by negative 2 to get the letter y alone. We get y equals 11. By inspection, just by looking, we can tell the answer for y is 11. We know the answer for x and we know the answer for y, so the solution to our system is the ordered pair negative 12, 11. Putting negative 12 in for x and putting 11 in for y and working this out makes 10. Putting negative 12 here and 11 here and working this one out makes 8. Okay, let's redo the same problem, but this time use substitution method. Step 1 in substitution method is to solve the first equation for one of its variables. Let's get the letter x alone. To do that, we have to subtract the 2y to the other side. X equals 10 minus 2y is equivalent to the first equation in the system. Step 2, we're going to substitute. What we are substituting is the expression 10 minus 2y in place of the letter x in the second equation. So 3 parentheses, and where the x is, fill in 10 minus 2y. And copy the rest of the equation down. Now solve this equation. 3 times 10 is 30. 3 times minus 2y is minus 6y. Next, some combining like terms. Negative 6y plus 4y is negative 2y. Next, subtract 30 from both sides. 8 subtract 30 is negative 22. Then divide by negative 2. We get y equals 11. Step 3. Now that we know a value of y, we can go back to the equation we created where x was solved in terms of y. Fill in 11 for the letter y. I'm getting this equation from the one I had created in step 1. Now solve this. 2 times 11 is 22, and 10 subtract 22 is negative 12. By inspection, we know the answer for x is negative 12 and the answer for y is 11. So our ordered pair is negative 12, 11. Be sure to put x first and then y when you do the parentheses. Let's try another example. Solve this. We're looking for ordered pairs x, y such that this equation and this equation are true. This is just another way to write a system. The first equation is 4x minus 2y equals 3, and the other equation is negative 6x plus 3y equals 1. The problem does not specify a method to use. We can use linear combination or substitution. Let's go with linear combination. Step 1 is to make the y terms be opposites. We can accomplish that if in the first equation we change this into negative 6y, and in the second equation we change this into positive 6y. Think about what you would need to multiply by in order to do that. In the first equation, we would need to multiply everything by 3. It will become 12x minus 6y equals 9. In the second equation, we would need to multiply everything by 2. That would make negative 12x plus 6y equals 2. Then in step 2, we combine these together by adding. 12x and negative 12x makes 0. Negative 6y and positive 6y makes 0. And on the right side, 9 plus 2 is 11. Something interesting happened. 0 equals 11 is a false statement. There are no numbers that you could substitute for x and y and ever make 0 equal to 11. This is one of the problems where there is no solution. The lines must have been parallel. So our answer is no solution. Or to save time, you could put the empty set symbol. Let's try one more example problem. Solve this equation and this equation simultaneously. Again, this is just another way to write a system of two equations. We have our first equation and we have our second equation. If you're more comfortable seeing the equations written above each other, you might take the time to rewrite like this. Problem does not specify which method to use. Let's use substitution this time, just for the practice. Step 1 of substitution is to solve one of the equations for one of its variables. I think the easiest one to solve for is the letter y in the first equation, because all we need to do is subtract the 2x. Then, step 2, we're going to substitute 1 minus 2x in place of the letter y in the other equation. It becomes 6x plus 3 parentheses 1 minus 2x equals 3. Now solve this. First, a little distributive property. 3 times 1 is 3, and 3 times minus 2x is minus 6x. Now combine like terms. 6x minus 6x is nothing. We're left with 3 equals 3. Again, something interesting has happened. 3 equals 3 is a true statement. What that means is no matter what numbers you put in for x and y, you will always get 3 equals 3. So this is the case where the equations are equivalent. There are an infinite number of solutions. Every solution to the first equation is also a solution to the second equation. Here's one way to write down the answer. Let's summarize the lesson. We reviewed how to solve systems of equations. There are 3 methods. The first is graphical. That method is best if you already have a graph of the equations or if it's easy to graph them. The second method is linear combination. That method is best if it's easy to make terms be opposites of each other. Third method is substitution. That method is best if it's easy to solve for one of the variables.